Okay, good morning. So this is a physics question, and it's under work, energy, and power. The question reads: the figure below shows a modern used to operate a lift or elevator. So there is a man in the lift. The input power of the motor is 6,200 watts. That is the sketch that I made there. The first question says define power, of which power is the rate of doing work. Even if you have got the same height, same mass, but if you are running a race and the one reaches faster than the other, the one that reaches faster has got a greater power than the one that will follow. So question B says the lift and the man have a total mass of 580 kg. The lift moves up a distance of 12 meters in 15 seconds. The first question is calculate the tension force in the cable when the lift is moving at a constant speed. So in short here, want to calculate force, and we know very well to say force is a pull or push, and is calculated as mass times acceleration. But if you look at this question, we are only given the mass, which is 580 kg, and we are not given the acceleration. And we should also remember that force is also equal to mass at a constant mass times acceleration, which is equal to, at a constant speed, is equal to weight. And we know very well that weight is equal to mg. And the m, it is the mass, and the g, it is the acceleration to gravity, which is 10 meters per second squared. And if you look at the question, it says the tension force is in the cable when the lift is moving at a constant speed. So at a constant speed, which means that force will be equal to weight, of which is equal to mg. So since we have got mass, then we are going to use the same mass to calculate the tension force, of which we are going to say force is equal to W, which is weight, and also equal to mg or ma. It's one and the same thing, whereby we're going to say, okay, mass times 10 meters per second squared, okay, which is the force to gravity. Right, then you found the answer there, and you know to say force is measured in newtons. The second question reads, calculate the GPE, which is gravitational potential energy of the lift and the man. So gravitational potential energy, this is the work done by an object or a machine to lift up something. So this is a work done to lift up an object to a certain distance. So if you look at this motor, has done some work to lift this lift, including the man, up to a distance of 12 meters. So how do we calculate potential energy? Potential energy is the mg h, where m is the mass and g, it is gravitational force, and the h is the height. And we are saying this is the work done by an object to raise something up, or work done by a machine to raise something up. Or in this case, we are saying this is the work done by a motor to lift the lift or to raise the lift at a distance of 12 meters, which will be the height in this case. So, and we know very well to say work done is equal to FD. Work done is equal to force times the distance, of which force, this is the tension force that we have calculated here. and the distance is this one. Or if you are to say mg, we've already have this mg here, which is mass times the gravitational force, or mass times the acceleration due to gravity, and we just multiply by the 12 meters, which is the height or a distance in this case. Okay, so this is, in short, this is what I've done here. mgh, so which is 580 kg times 10 times 12, and you have this, and the work or energy is measured in joules. So this is the work done by the motor to lift the lifted man to a distance of 12 meters. Then the next question reads, calculate the efficiency of a motor. Calculate the efficiency of a motor. Efficiency, this is the ratio of power output over power input, or energy output over energy input, then multiplied to 100%. Okay, so now if you look at the question, we are told to say there is the input of power. The input power of motor is 6,200. So this is the what the power input. Now we need to calculate first before we find efficiency. We need to find out what the power output, the power that was now used. So this 6,200, it was the power that was put. That is input that was put. Now we want to know, to say, okay, this is the total power that was put to use in the motor. Now, what was the power that was used? Is it that the whole power was used up, or the certain amount of power was what was used? And how do we calculate power? We know very well to say power is equal to work done over time, of which work done we have already calculated, which is the gravitational potential energy in this case, because work done is equal to gravitational potential energy, because this is the power that was used to raise the lift to the distance of 12 meters. Or if you want to calculate work done alone, we can simply say work done is equal to FD, force times the distance, of which the force is calculated as mg, and multiplied by distance, of which there it is the same 12 meters, whereby you are going to find the same answer of this one. We are going to find the 69,600 joules. So now, since we already have the work done and we have time, this motor had to lift has to raise the lift upward distance of 12 meters in 15 seconds. So we have time, which is 15 seconds. So what we are going to do here, we're going to say, okay, fine, power is equal to work done, which is work done over time, whereby work done, it is 69,600 joules. You divide it by the time, which is this one, 15 seconds. 15 seconds. So, and when we evaluate that, 69,600 divided by 15, you are going to find 46. You are going to find the 46 or 40. So, which is watts, 4,640 watts. So this becomes the power. Becomes the power output, the power that was used up. Okay, so this was the power that was used, and this is the power that was provided, and this is the power that was used. Therefore, we can easily calculate the efficiency, whereby you are going to say efficiency is equal to power output, the power that was used, power used, divided by power that was input, okay? Then multiply by 100%, whereby we're going to say, okay, fine. The power output that was 4,640 over the power input, which was 6,200, and multiply by 100%. And when you evaluate this, we are going to find 75%. So that was the efficiency, that was the ratio of the power input, the power output to the power input. Okay, the last question was describe the energy transmission in the motor while it is moving upward. Describe energy transmission in the motor while it is moving upward. So energy transmission, you know very well that the conservation of energy states, the law of conservation of energy states that energy cannot be created nor destroyed, but it can only be transformed from one form to another form. And we have the several forms of energy, like kinetic energy, electrical energy, whatever energy, potential, mechanical, chemical energy, all those. So what will happen in the motor, what we find, it is electrical energy. Okay, so we find the electrical energy in the motor. So this electrical energy will be converted into what? Kinetic energy, so that it can raise the lift up. Okay, and when it is converted into kinetic energy, as the lift is being raised towards the distance of 12 meters, the kinetic energy will be converted into potential energy. Why? Because mechanical energy is causing the motor to move the lift up, and when the lift is moving, the energy that exhibit is what? Kinetic energy. And towards the stop, the kinetic energy is converted to potential energy, which is the energy that a body exhibits when it is at rest or at a stop. Okay, so this is what we can learn from this question, and energy, under power, and also work. So these are the most key concepts that we need to know, and calculations that are based there. Thank you.